So, good afternoon, everybody. Buonasera a tutti. Buon pomeriggio. I am the director of the Italian Cultural Institute in Addis Ababa, and I'm very glad to welcome you here on this webinar. I have to say this is also the first webinar held by the Italian Cultural Institute due to the pandemic. And, well, it's been for everyone hard times, but probably this is leading also to innovate, to find new way to communicate also with you. So I cannot see you in this moment, but I'm so glad that all of you are here attending this webinar. Why did we organize it? We organized this webinar together with the Italian Association for Industrial Design, together with the Italian Foreign Ministry, and with the help of some faculties of architecture in Ethiopia, like the EiABC, which is the Faculty of Architecture and Construction Building of the Addis Ababa University, with the University of Arba Minch, and also with the AASTU, which is the Faculty of Science and Technology. Yes. So why? Well, usually Italy is used to celebrate the Italian Design Day in the world, which of course got completely sat up down due to the coronavirus, and we could not invite, as usual, ambassadors of Italian design. So what we could do this year is something different, which is inviting our ambassador of Italian design for this year only virtually. So he's not here with us in Addis Ababa. They are, because there are three, in Venice at the moment. And it is a studio of architects, which is named TAMassociati, and they have huge experience in social-oriented projects and also projects abroad and in Africa. What is really interesting of them, it's a lot of things, but what may be really interesting also for us here in the Ethiopian context is their approach. They are used to adopt vernacular and traditional techniques and match it with innovative approaches. For example, and one of the examples, of the newest examples, is the Pediatric Center in Uganda, which has been designed by TAMassociati together with Renzo Piano Workshop. So, what can I say more? What are you going to assist now is the presentation by architects from TAMassociati Studio, which are architect Raul Pantaleo, architect Valentina Milan, and engineer Massimiliano Milan. After their main speech, I think we will have space and room to discuss all together through a roundtable moderated by architect Fasil Giorgis, chair of Architecture and Urban Conservation at the Addis Ababa University. So may I now, before introducing our guests from Italy, give the floor very quickly to architect Fasil, who will better introduce the participants to the roundtable.
Thank you. Thank you. Can you hear me? Thank you. Okay, thank you, Francesca. I would like, first of all, to thank the Italian Cultural Institute for organizing this webinar. This is probably the third, or I think the third webinar, no, not webinar, workshop we are having with the Institute. Last year we had another one, but a live workshop with our students. And this year we are very fortunate to have these architects, Italian architects, who have been working in Africa on sustainable construction. The participants from Ethiopian side are, besides my institute, the Ethiopian Institute of Architecture, Building Construction and City Development, we have also the Arba Minch University, which is in the southwest of Ethiopia. And then we have also people in the AASTU, which is the Addis Ababa Science and Technology University, which is also a little bit on the outskirts of Addis. We have tried to invite also professional architects will just be tuning in to listen or to attend this presentation. And once again, I would like to thank them for their time and interest to share their knowledge and their experience in Africa. And I hope we'll all learn something and have a pleasant discussion at the end of this presentation. Thank you. So you can go to the presentation. Thank you.
Microphones. Can we now give the floor to Pantaleo? Luca, can we give the floor to Raul Pantaleo now?
I can hear you. Here we are. Well, thank you very much. I'm so happy to be here. Unfortunately, not physically. I mean, I was dying to come to Addis that I just passed through with the airplane, and so I never enjoyed your country, but I hope this is just at the beginning. So what I would like to share with you is this experience more with that is, I would consider more a collaborative experience. And in this spirit, I invited also from our team, Valentina Milan, that she has been the chief architect of the project, and Massimiliano Milan from Studio Milan Engineering, that has been the chief engineer. And because I think that they have been deeply engaged in several aspects of the project, particularly the design aspect, but also the design in terms of wider group of people that were working with on a beam base that Valentina will explain. And for sure, Massimiliano will go deeper in the aspect of the technological aspect of using rammed earth in the construction. That has been the more interesting aspect that we developed in this project. So I would like just to make a short presentation of some project that we did in different country of Africa, just to share with you our experience in terms of using sustainability as a guideline for our project. So I would like to ask Valentina if she can share the screen. So as I was mentioning, from our side will be myself, Valentina Milan from TAMassociati, and Massimiliano Milan from Milan Engineering. Next. Next. Of course, as usual, when you need it doesn't work. Yeah, okay. I just want to start with our organization, not because I want to show ourselves, but because I think that, especially in this period, our organization in terms of office, we are an association of architects. So it's a sort of a nuclear organization, that a satellite organization with a different bases that has been quite helpful in this period of COVID, because we were used to work from remote, to work in a collaborative way, in a horizontal way. So the idea of working on such a complex project in different countries, different contexts, start basically from the idea of a collaborative approach. Next. So here you can see the spots where we have been working. We set in 1990, and since the beginning we decided to work for project in the American ways. It's called impact design that is following process and environmental changes in the world. So basically, we have involved in environmental and social impact project in different parts of the world, in Africa, in Central America, in Asia, and also, of course, in Italy. What I'm going to share today are just few projects that has been focused basically on the African continent. Next. And I would like to start with a sentence that was said by the master jury of the Aga Khan Award that we won in 2013, that is summarizing somehow our approach, that it is possible for a low budget project to combine functionality within design, utility with beauty, affordability with excellence. And I think that the jury has been focusing perfectly the approach that we want to share in our work. Next, just the first project is an example of that's a recent project that we developed in Kenya, in Kisumu, for the Aga Khan Foundation. Next, I would like to show how this complex approach to the design, that is, we can call it a global design, that is merging sustainability, social sustainability, impact design, the human approach to the design is a system that is ending up in design action. So the design is part of the process. And here you see, this is just the rendering of the hospital, but I just would like to show how we ended up to design this hospital through the approach that starts from sustainability. Next. So basically, the first thing we do normally in any project is to study the environmental conditions that are surrounding the project. So the design starts from a deep attention to the natural resources, to the natural position of the building, and how we can work on the passivity of the building to perfection the capacity of the building to react to the environment condition. So here, just to show what has been the result of this approach, has been to design a very compact building with a central courtyard that works like a chimney to implement and to generate natural ventilation. So from this point of view, we start from designing also all the equipment, try to minimize the use of equipment, to minimize the use of energy, to minimize the use of resources, in this case also of recycling the water, the rainwater harvesting to be used for cooling and for other activity in the hospital. And here you see the first result, just to explain what is our goals. If you start on a benchmark of a standard hospital using 81 kilowatt of energy, electric energy for the cooling, we gave to the client two different options using all passive approach of the building and to use natural ventilation, to use renewable energy. We could reduce the energy demand to 11 or 12 kilowatts. So we reduce almost 1/7 the use of energy. So this is somehow just to give you, you can go now, Valentina, to give you a clue of how the design of a building starts, not from an abstract idea, but start from the environmental impact of the building that is leading the design. What I would like to share with you now are some examples of hospital that we designed for emergency. Emergency is the biggest Italian NGO, like Médecins Sans Frontières. It's an NGO that works since 1994, basically all over the world, providing hospitals that are giving health treatment free of charge in different regions of poverty, of war, or in very complex contexts. Next. Specifically with the project called African Network Medical Excellence, this project specifically was organized through the NGO with the Ministry of Health of several African countries, by the way, also Ethiopia, that with the idea of setting in all different countries center of excellence, and that center of excellence could spread their service to other countries. So to create a network of hospital of excellence to provide healthcare to the whole continent, flying using, of course, airplane and this kind of connection. So the first example is a very old hospital, 2010, is the cardiac surgery hospital that has been based in Khartoum, and is called Salam Center. It's a small hospital that is providing cardiac surgery. So, this hospital has been somehow the first hub of this network, and the hospital we are going to share with you today of the Uganda Pediatric Hospital with Renzo Piano is part of this network. As you can see, the hospitals are, you can go next, very basic structure, very, very simple, using as much as possible the local resources, but using especially the capacity of the hospital to be embedded in the surrounding. As you can see here, we are on the shore of the Nile River, sorry. So the use of the green has been, of the nature has been the basic element to design the hospital. So the hospital has been designed around the natural resources. And here, just I go briefly, this has been one of the biggest installation of solar panels, water solar panel, to transform the heat of the water of the solar panel in the cooling of the system. So this has been one of the most innovative projects at that time in cooling in desert area, using solar resources and using water cooling. Next example of using the resources is the container compound, that we use the container that we brought in Sudan with the medical equipment, and we transformed the container, 92 container, in the compound for the medical staff. Next. So you see again here, the use of this double shell to protect the container from the direct sun has been essential in the approach of the sustainability of this project. Next. So again, here is all the hospital is designed around the garden and the green that is present in that area. So with this project, basically, we introducing also the plantation of the garden. We could save 76 tons of CO2 emission. Next. These are just a very small project that has been developed around the Salam Center. There are two examples in Sudan that are hubs that are serving the main hospital. As you can see, again, the hospital has been designed in a very, very low profile in terms of integration in the genius loci of these small cities that are in Sudan, and has been inspired also by physiognomic elements that are typical of that culture. So also the wind tower that you can see that is growing up is part of also to this approach of designing a project that can be understood by the local population. Next. And here, this is the central garden. The gardening is the crucial element in the process of healing. Next. And here again, we developed the project of adiabatic cooling. Basically, we catch the air from the wind tower, bring in the basement. The air is washed, and then with adiabatic cooler, we inflate the air in the building. So through the passivity and this system, go back, please. We could succeed in cooling 800 square meters with 6 kilowatt. That basically is the kilowatt you use for an IC, just we could cool all the hospital. Next. The other example is the pediatric clinic in Port Sudan. Port Sudan is an important city on of Sudan. It's the main harbor with a lot of problem with the refugees coming from the different war. And again, here the clinics has been designed starting with the idea that we want to bring in that desert a garden. So the design of the clinic start from this idea of recycling the water and to generate a system of of recycling the water of the clinic to generate the garden. Next. And so here you see this became sort of outpost of in that area, because next is the only garden that is present in this huge desert area. So again here the next, the design of the hospital start from the approach to sustainability and to an environmental design. Next. Next. These are some slides of this is a very small clinic, and here again we improve more and more the system of the adiabatic cooling that we experiment in the different hospitals. So we succeed in cooling the hospital with a very low energy. So this has been extremely successful because give to the hospital an extraordinary resilience in terms of approach to the local context. So the limit of electricity, the limit of energy, and the limit of resources. So now we come to the pediatric clinic, hospital, sorry, in Uganda, that has been this extraordinary experience that we developed with the Renzo Piano Building Workshop and together with Milan Engineering. So it's a 78-bed, so it's a small hospital. It will provide surgery for the whole region, pediatric surgery, and it will be somehow the second hub of this African network of excellence hospital. Next. So it's based in Kampala. It's very, very close to Entebbe. So as you can see, also in the approach of the organization of trying to choose a location that is giving quality to the patient, because also the nature is part of the healing process. Next. So we give the floor to Valentina to explain the hospital. Voce, Valentina.
Yes, sorry. Hi to everyone. So we saw this this hospital is placed. Just a second. I cannot control anymore the presentation. By the way. Yeah. Okay. So the hospital is really close to Victoria Lake, so the relationship with nature and water, it's very important, and it's close to a residential area and close to a barracks area, so military area, and then it's facing the Victoria Lake. So the structure, it's a comb structure with three main buildings, let's say 4 with the guest house and 5 with the entrance blocks. So so these 5 blocks, we get to the entrance, and then we pass through all the buildings with the entrance and the examinations area, and then we have in red all the operation theaters and ICU functions, and then up here we have in light blue the ward area for children. So it's important to say that that's a hospital just for children, and so because there are young people staying in this place, we thought, but it's something very common in the project of the emergency too, to have a guest house where the family can stay during the stay of the children's here, so for the family too. So what we can see in the pictures as well is that the walls of the hospital are the same color of the earth we can find here. So it's very the walls. It was the main aspect of this project because they're made of earth themselves, and the earth they're made of. It's the same earth that was excavated during the construction side. So then Massimiliano will explain better also this aspect. So the relation with the nature is always important. So we have this main garden facing the whole hospital, which it's built on a slope a little bit. So here we can see the color of the earth, which is very powerful, may I say, and it's very strong. And also the texture of the earth is the same to the wall than in the final result. Here you see the construction, some construction site pictures. So the color is very strong, of course, and the view from the inside is toward nature. Toward green and toward the lake. So here's the entrance block where the family can stay to then go into the hospital. And from here you can have already the view to the lake. And here it was finished. So we have this important, so we have two roofs here. One is the roof of the hospital and one is the photovoltaic roof we will see then. So always the green is very important and close to the hospital. So here we are in the main courtyard between the two main buildings, and here you can go down to the administration area or up to the ward part. And here is the guest house, where is the entrance of the guest house where the family can stay during by their children. And that's the side facing the lake. So I was telling you before that this technique of Bizet that you may know, it's a very ancient technique of building walls with earth, with soil. And it's very traditional in some of African countries. So how it works, and between two walls, this earth is pressed. It's a mixture of earth and sand and normally, traditionally, but with the help of Milan Ingegneria and many researches, we improved this the structure of this wall. What it's very interesting by the architectural side is that the texture and the color of the walls are really disappearing in the landscape. And it's everything together with the soil, with the real soil, with the existing soil and the existing nature. And here, so you have a map of the wide areas in the world built with rammed earth. So it's a large part of the world with which use this technique. Not Bizet in particular, but generally rammed earth. So here where the first experiments done with local peoples, to see how the mixture could be and how. So this is the very first mock-up, very artisanal one. So that was the first trial. So, and here was the final one that maybe Massimiliano will explain better. So you can see here that the texture, the horizontal line, we have the layers. You can really see the layer of pressed earth on the material. Massimiliano can talk about more specifically about the wall, I think, in a more technical way.
Thank you, Valentina. Thank you, Raul, and thank you everybody for inviting me here. I'm Massimiliano Milan. As said before, I was the structural engineer that followed the hospital in Uganda. I'll try to explain the rammed earth technology and mostly the rammed earth technology applied on this project. At the really beginning of the project, we fixed some objectives. There were structural safety, durability, and sustainability. Structural safety, of course, we're talking about a hospital, so have to resist to static load, earthquake, wind loads, and so we had to take into account all these forces and improve the best structure to guarantee safety and mostly to be the safer building in the whole area, so it could be a safe place to be in case of everything can happen in that place. The durability, if you can go back, durability is also something to take into account. Of course, we're doing a hospital for a ONG, so we have to minimize the maintenance and the renewal, the restoring works. So that's something also to take into account in a hospital like that, and sustainability. Of course, you saw in the picture that we're staying in the green coast of the Lake Victoria, so it's something that was, of course, in the goals of TAM and FBBW, but it comes out automatically in this place to take care of the sustainability side of the project. To solve this, we will see now the technology that we improve to reach these goals that will focus on the mixed design, on the construction process, and on the accurate structural design and engineering of the project. So we can go forward. I will try to explain the technique and the solution going backwards. So from the construction to the design, the first step was the excavation. So we excavated to do the underground floors and the foundations. You can see the wonderful color of the earth, and that was an important step for the project because actually from here we took off the clay and the silt that we used to build the walls. The clay and the silt was sifted just to take, as I was saying, the clay and the silt, not the gravel, not the organic materials that's inside, or the bigger size grain that you can find in the soil. And that was mixed with other materials. The mixture that you get at the end is really well studied with accurate ratios of every material, and that is called mixed design, and I'll go back. I will go back on this later. So all the elements are mixed together to get a good consistency. You can see here are mixed in a concrete mixer, and they to get the right consistency that doesn't have to be too fluid, but not even too solid. And we can go forward. Then the mixture is contained in the formworks, similar to a concrete formwork. Actually, these are the same formwork for concrete, and the mixture is put inside the formwork and pressed. The formwork it's really important, mostly for the architectural side. So as architectural concrete or every cast material, the formwork gives the texture on the outside that we want to reach. So having a good formwork brings you to have a good surface finishing. So that was really important. So not only the material that is contained, but also the box. It's important to have the good finishing. So the rammed earth is compacted inside the formwork. That is really important to have the right compaction of the material, because rammed earth increases resistance proportionally to the energy with which you compact it. So better you compact it, a better material you will have. And so that's really important for rammed earth, generally speaking. Every layer you put inside the formwork, more or less, it will end up with a 1/2 of every layer. So also this you have to take into account to understand how much material you have to use and how to reach the level that you want. For example, here you see a detail of the formworks of the windows or of the doors. And that's something important to have the layers that we studied with TAMassociati and RBW. The alignment of the windows had to be the same, first for architectural reason, and second to have the lintels and the lintels of all the windows and all the doors to get aligned with the layers of the earth. Both for construction reason and for architectural reason. We can go next. So here you see the proceeding with the walls and the mounting of the formworks. And here you see the first 3 layers that was used between the concrete and the earth. There was a fiberglass layer that is really useful to that Uganda is a really humid place, and it's really important not to have humidity come up to the wall from the ground. That's really important for the durability of the wall. This image is tells something about how to do rammed earth. Rammed earth. When you finish to cast it, you take off the formwork. It's not finished the work. You have to mature the material. So you have to keep it wet. A big problem for rammed earth is the shrinkage. What's the shrinkage? The shrinkage is actually the volume that because of the evaporation of the water dry the material, and so it becomes smaller. The volume decreases. Because of this, you can, if you can go back, for this reason, the material can crack a lot, and rammed earth can crack really easily. So to limitate this effect, you have to keep it wet for a long time, and this you have to do it even more in such a warm place as Uganda was. So we kept it wet for 1 month after the construction, and after we saw in the next slide, we saw the results, so minimizing the cracks. Also on that, I'll go back on these arguments later. And so the curing of the wall and the keeping it wet, it increased a lot, both the resistance and the finishing, and not to have cracks. That is also really important. Before I was telling about the mix design. So the mix that has to be done for the material. If we go next, what I want you to focus not on all this number, but mostly the compression resistance and the density. You can see different materials here. So the steel is around 400 megapascal, concrete around 40 megapascal, brick masonry about 3 megapascal, and that's the compression resistance of a material. The classic rammed earth goes usually 0.5, 1. If you do it really good, you can reach 2. So have a low compression resistance, the classic way of doing it. In this hospital, at the really beginning, we said, okay, we have to find a way to do it better and to reach a higher compression resistance, because we're doing a hospital and this is not enough. for the resistance for the project that we're doing. So with that more than one floor, it's the 2 floor, it's really deep, there's heavy machinery to support, so we have to increase that. So, but we wanted to first, we wanted to reach the goal to have this rounded wall. So we studied the way, and we developed a mixed design with also other stabilizing agents. So from the classic rounded, we developed another one with in which we added other materials. And if you can go back, every material have a. If you can go back, please. Every material has a meaning. So of course there's the clay and the silt that we found on place, also the sand. But the gravel, we increased the quantity of gravel that is really needed to improve the resistance of the material. So we did a lot of tests, and we tried the different quantities of gravel, and the gravel allowed us to improve a lot the resistance of the material, the compression resistance of the material. Then also we added the MappeSoil. It's a stabilizing agent. It's a hydraulic stabilizing agent based on that activate the pozzolanic action of the material and cement. These two materials, it's a really small quantity compared to all the others, but are really important to activate a chemical reaction, exothermic chemical reaction that actually harden the material. So in the classic rounders, we do not have the only chemical reaction we have is evaporation of the water. In this case, we had to make it happen to harden the material and to reach the resistance that we needed for this material, mostly because we're doing a hospital. So as we said before, it had to be a safe place. The fibers are really useful to limit the micro fissurations of the walls. And dynamon, it's a super plastifier. It's a super plastifier. And water also, it's something really important, because with the material that I said, water is needed to activate this chemical reaction. So we used a little bit more water. In rounded, we can go next. Water is always really important, and you always have to keep it under control. Because if you increase too much the water, you will have more shrinkage, so more fissuration, and and the worst resistance of the material. We did many tests. And to understand what was the best mix design, and define also not only just resistance, also to see the aesthetical result was good. And we did a lot of tests, and finally, with the stabilized render, with the description that I said, we reached 8 megapascal of compression resistance. That is more or less 8 times the resistance that we have in the classic round earth. Also, another parameter that I said that is really important is the density. As I said before, more you compact the round earth, more resistance you have. So increasing the density and compact it well, and the mix design, new mix design, is easier to compact it. So you reach a higher density, so a higher resistance. So that was a really important parameter to take into account. The last test that we did in the first mock-up was abrasion resistance. So actually, you just go there with a steel brush, you brush the surface, and with 10 scratches. And in the classic mix, with the classic mix design, so old style round earth, with 10 scratches, you go inside in 1 centimeter. There we have that means that actually, if I would stay there half day, I would go on the other side of the wall. So that was another problem to solve. And the new mix design actually has a a wonderful resistance to scratch. This is not because someone had to go there and scratch it, but actually there is a lot of rain, the wind, the sand passing through, so it's something to take into account to ensure the durability of the surfaces of the wall and of the structural walls. The last thing that is really important after the walls are finished, after the construction can end and after the curing of the walls, we treated with the surfaces with a silicone-based material. It's a cream that you just put on the surface and that protect from the water. So it's a water repellent material that avoid penetration of the water inside the walls. And this sample, that was a mock-up that we did, and after 12 months, you can see the difference between half side that was treated with the silicone-based treatment and the other one without it. So it protected protecting it from the water, it also protected from organic attack. You can see here, for example, some samples that we did inside after 12 months. The surface is still perfect, and you can see that this protection penetrates 1 centimeter, and so ensure the protection of the walls if there's not holes or cracks in it. So that was another important side to keep into account to control the cracks. So we did a lot of tests. We did a couple of mock-ups. That the first one and the second one. The second one was in Italy with a really bad color of clay. So I said that the shrinkage is really important. We control it with some construction joints. So we knew that the walls could crack, so we did some joints and some induced cracking joint. You can see the red one on the right. So we knew that actually the wall could crack, but knowing that, we said, okay, we're going to decide where it's going to crack. So inside that line of induced cracking to have the control of the crack, and so that's the result on the surface that was also coordinated with the architecture to have a modularity of the wall, so to have it coordinated with them. Another thing that is really important is all the angles of the walls. Maybe in the next image it's more clear. All the angles have to be cut and been decided to cut off, both for architectural and for technical reasons. So the angles are really hard to compact. So all the angles can be have been cut off, but also coordinated with the architectural choice to give a good effect to the geometry of the walls, but also to avoid to break it after the construction and after the time. So all the angles you can see that are smooth. We can go forward. There have been other technologies applied to the project. So there was the steel structures and of these slabs and the independent canopy. And to attach it, we did some concrete curves on the walls. These curves were also used as lintels on the doors and on the windows. Here you can see some pictures of the. You can go forward of the construction side. So the steel structure, internal steel structure, and the walls were going on the same direction until the end that you can see finished. So the steel structure and the rounded walls at the end of the project. Thank you, Valentina, leaving the floor again.
Yeah, thank you, Max. Yeah, I talked to you about sustainability and this double roof we have in this project. So that also Massimiliano showed. So when we talk about sustainability, we have many aspects to see. So the wall here is very thick, so it's 60 centimeter thick. So that means that the heat takes a lot of time to get in, and so we have very low transmittancy, and the fresh air is kept inside. So and also, if we have to talk about sustainability, we have the second roof, which produces 289 kilowatts. So that means more or less the 30% of the consumption, of the general consumption of energy of the hospital. So rainwater was reused. So there is a big basin for reuse of rainwater for mostly for the fire system, and of course the reuse of the excavated earth, as Massimiliano told you. So that was the layers of the walls. So as I said, there is an extremely low embedded gray energy using rammed earth walls, and of course, so here you see the curve going down. So it's very low, the time of the transmission of quantity of heat. So this is the roof. So you have a wonderful view also from the roof, maybe the best one, and the in-between space for, of course, for a technician to go and repair in the future. So we talked about nature and nature as a healing factor. So it's very important that like in this case, a hospital is placed in the nature and in relationship with it. And also the choice of trees and local flora was very because the process needed, maybe you don't see the screen anymore. I don't know if there's a technical problem. But anyway, the trees were chosen were trees that were somehow we could find there. So they were not imported from very far away, but were local trees, of course. And of course, here is very easy also to grow plants because of the very nice environment. So what's interesting about the relationship between architecture and here you can see the relation between architecture, so building, and nature. And here's the main garden. So maybe they have to grow a little bit more then. So the lake, again, the central yard. So what was interesting during the site, that all the trees that was planted there, they were put in air pot in a nursery right into the site, so by the site. So we found small trees, and during the construction site they grew. So so they're all like the building. So they started with the building as well. They were not planted afterwards, but before, and then they were just set in the final spot after the construction. And so here was the space for the nursery, so it was really by the site. And then these small trees, then they were put in the garden and in the area. So what was very interesting about this project was also the process. So it was not a linear process, like always happens with emergency too, and with NGOs where you don't have never-ending resources. That the design strategy runs parallel to the availability of materials and know-how. So if we don't find a special plant or a special material, we have to decide for something else. So something which is available and has a limited cost. So availability of money, of course, of materials and know-how. So if we have people that know how to do something or not, in also locally. So it was a big team, that's for sure. And it was a very advanced team also. So how we worked between beam design and analogic design somehow. So we used, a platform, a cloud platform for beam design. So building information modeling with Revit. But parallel, we of course we used sketches and we exchanged both information, of course, in from all over the world, because we were in Italy and the client were in Milan, and then the site was in Uganda. So it was a wide exchange of information. So we had this Revit model, the building information model, where we put all the information, but then we use also models, built models, so physical ones. And so we composed both technologies to work on. So that was a little bit how we worked with between very high technology and hand too. So maybe Raul, you want to tell more something about the interior space?
Well, just to close up this presentation, we try to give more space to the debate. I think that we put on the table a lot of different approach to the project, that was from the technological aspect to the building aspect, and also the process that Valentina was mentioning has been an extraordinary experience, because as you can imagine, to work with Renzo Piano is one of the biggest architects in the world. It has been something really extraordinary, but when I'm talking of collaborative platform, is not only the BIM platform, BIM, but also the human approach to this project has been essential in succeeding in this result. So just to finish our presentation, we will go through the work that has been done trying to design a hospital that was tailored around the needs of the children, and also the imagination, the spirit of the children. So the use of color, the use of natural element brought inside the hospital has been essential. Okay, next. So this is just to end up somehow, if we start, you can go next. If we start, when I was explaining the first slide of our approach in terms of a human approach to design, I think this example, it's a good mixture between high technology, because at the end of the day, it is a very high standard in terms of performance of the building, in terms of result, aesthetic result, technological result. But the extraordinary thing is that within this process, there has been always a deep relation to the final result, taking in account the budget issue, because of course the NGO has a limited budget, and you can imagine such a sophisticated hospital has to be squeezed within this budget. So I think this somehow is proving what we were mentioning at the beginning, that like the Aga Khan jury was saying, it is possible. Of course, we have different scale. This is a very high standard hospital, and the other hospital were in a smaller scale, but with the same approach, that is a collaborative approach, with the same spirit in terms of sustainability, that is not only sustainability in terms of environmental, but is also social and economical sustainability. So it's a whole approach to ecology, economy. So this, I think, is a good example of an approach that can lead, what I will always like to say, to the design of the Anthropocene area. So we are facing now big changes, also changes that somehow has to redesign our way of thinking the development, that we have to face the issue of climate change. So there has to be a big change in terms of approach, in terms of vision in design. And as architect, as engineer, we are part of this approach and this vision. So that's why I think that the picture we were showing of this round table around the Renzo Piano workshop, it is a good example of how we can face the big challenges that we are going to face in the next future, because of the pandemic, because of the economic crisis, because of the environmental crisis. So it is possible to face these big changes with new innovative tools that somehow are merging together this different element that is all together going to a sustainable approach to the future. Thank you very much.
Yes. Thank you for your presentation. Can you listen? Can you hear me?
Yeah.
Yes. Thank you very much for your presentation. This was quite interesting and very eye-opening. I think if I, from the experience we have in this country about design and construction, there is this thing about sustainability, environmental design, and so on. But your project has shown us a kind of very holistic approach, which involves consciousness, environmental concerns, technology, and so on, and how you can bring together these different aspects in a social project like a hospital, which is quite appropriate. I think without saying too much, I would like to leave the floor to the audience, whoever wants to ask questions. I think especially the panelists who are Rahel, Groom, and so on. I think you can start to raise the questions. I would like to forward it to you. These are colleagues from different universities, as I mentioned, from practice, and 3 different universities. They will be asking questions, and please, when you ask questions or give comments, tell your names and from which university you come, and also mention the person you want to ask to direct the question. We are not going to, I think I told Valentina yesterday, we have a different culture of answer and questions in this country, which is like you don't answer for every question. We collect 3 questions, 2-3 questions together, and then you can answer, because questions usually can be repeated or can be similar or the same. So let's see. Let's start with the first group of questions. Thank you. Oh, back to, I think, yes. Whoever wants in the panel to ask questions, first mention your name, and then you will be directed to the, yes, Rahel, you want to ask question? Yeah. Yes, go ahead, Rahel.
Thank you. I'm very glad to be the first question. Thank you all for the presentation. Now you can hear me?
Can you hear her question? No, I think.
Hello? Okay. No. Okay, I'm using my headphone actually. Is it? Hello? Okay.
Okay, let's try. Okay, I think there is some problem with Rahel's maybe microphone. Let's go to architect Grum Mamushet. Architect Grum, can you ask your question?
Okay, thank you very much. Can you hear me?
Yeah.
Yes.
Okay. First of all, I would like to say that we are very honored to be invited for this presentation. And my name is Grum Mamushet. I'm from AASTU, Addis Ababa Science and Technology University in Addis Ababa. And I really appreciate the presentation and all the effort and the product and everything. So to minimize, to use my time, let me just ask one question. So mentioning that this is a very interesting project, and my question is, by the way, for Raul. So you said this is very high standard hospital, and we can see that it's very complicated from the construction, the detail, the engineer's effort, and also all the process and the product. So how visible it is for, in terms of cost and also techniques and so on, to other residential building, I mean, small scale architectural products, so that, because first we say that it's vernacular or related to local materials and techniques, but from the presentation I can see that it's very complex engineering product. So how visible it is to use in small projects? That's my question. Thank you very much.
I think Raul, did you get the question?
Yeah.
No, let's do this. I have a suggestion. I'm starting to understand that there is an audio problem. So why not write your questions on the chat? Write briefly your questions, and you, the presenters, can answer. Luca, can we do that? Can we do the questions with the text, and then you can read it in the chat, and then you can answer afterwards? Because I think it did not work for 2 people. We can try Mahader, who is now, I see Mahader on the screen. Mahader, do you want to ask a question?
Microphone.
Mahader?
Can you hear me?
Yeah.
Yeah. Ask your question.
All right. Buonasera.
Guru, please write your question on the chat, and then it will come.
May I continue?
Sure, go ahead.
The present was a very interesting presentation and well thought out. I have two questions. Buongiorno to start with for our Italian friend. My first question will go to Massimiliano Bilan regarding the structures. On your composition, on the mixed design, I saw a couple of adjustments for waterproofing characteristics. I know from what I searched, Uganda, there is a very heavy rain, and it would be nice how you manage the waterproofing characters of the rammed earth. I'm just curious about that. And the second one is on the test that you did. When you did the tests for the compression tests of the rammed earth, you made some destructive compressive tests. How do you went into the next stage after you do the test out of that? How was the remedy after that? Because it was going to be a hollow part, and rammed earth are usually compacted from the top. So that is my question to the architects. I'm just curious about the layout. It's a very flat area, and was it intentional to make that system for that particular site, or you're just experimenting on the architecture? The system of the rammed earth came through the architecture, or it was a structurally driven volume detail? Because in hospitals, usually you require wider doors and windows, and on your details, I saw very interesting lintel, but the door sizes, they are relatively narrow. So what was the limitation of the system in coordinating with your architectural concept? Thank you.
Did you get Mahader's question?
Yeah, very clear.
Raul and Valentina and Massimiliano.
Yes.
Did you understand the question?
Yeah, very clear.
You did?
Yes.
Okay, let's probably start with Mahader's question, and we'll go back to the two other questions. In the meantime, is this Luca? Is it possible to somehow find the text to come up for the other questions for the other members of the panel, to like a chat? I don't know. It's a question for Luca if it can be managed, because the voices cannot be heard. I think it is poor internet connection. I don't know.
There is no question, apparently.
Yeah. Okay, let's go ahead with Luca and Valentina and Massimiliano for the questions that Mahader asked, the last speaker.
Yeah, I would like to start with in terms of design. I can explain you how it happened with this idea of working with rammed earth. We were at Renzo Piano discussing about the project and dreaming about this project, and I was just saying, well, maybe we can experiment the idea of using earth, because he saw this picture of red soil, and we said could be a good solution to start to think about this project starting from the excavation. And so we start to think about to go. We went to Crater in France. This is the center of design for rammed earth. And we start to imagine how he could develop this project through the technology of Pisé. So basically, the design has been influenced by the technical choice, not vice versa. So of course, we have limitation because of the technique, or in terms of size of window and lintel and all that. But basically, it has been a group work that was the whole team that was designing the project according to the technical specification, structural specification, and energy performance of the building. So basically, the design has been following the technique that we choose. And just I answer also to the first question is because it's very much related. Of course, this can be scaled down, definitely. In terms of you can definitely use the same mixed design, maybe less sophisticated because this is a much bigger building because it has two-story building and very long span. It is it's a very big building. So I think that we are sharing this information because we would like the technique of rammed earth design can be shared, spread it. I mean, we are trying to make also experiment in Italy with other projects that we can use the earth also to be printed. It can be used with 3D printer. So I think that of course this is somehow the maximum level in terms of complexity, but definitely all this information can land on a more easy scale of construction in terms of complexity. Of course, it's an open issue. I mean, of course, here we had also the technology available to experiment in terms of sealing, in terms of what Max was explaining before. But now this research is done. We know a lot of things, and these numbers are available. You can have it, and of course, we hope in a sort of open mind, in an open source project, that these things will develop and will become a different technology. So basically, we start with the traditional technology and we develop this technology to a higher standard because we know that all the many of the experiments that has been done with Earth has been a big failure because of durability, because of strength, and so. So I think that this is just a small step forward to the use of the technology. Finito.
I maybe will answer the questions. I will connect with what Raul is saying about, and to answer also a little bit to Jerome, that yes, it's true that it was there was a lot of research in the technology that we use, but as Raul is saying, it is easy now to scale it down because it took a lot of time to understand the good mix design and the right material. We did a lot of tests. It took almost 9 months just to understand the correct quantity of each material that we had to choose. But as Raul was saying, now it's done, and it's not a so complex technology to construct now, because actually the products that are used are simple, and there's nothing, and we're not hiding the products. We just show in the presentation with the right percentages, and it's something that if it is going to be used, this technology will be really happy because it means that pushing forward the sustainability doesn't go only in a big project but also in a smaller scale project to involve more people to the philosophy also that lead the project. And to answer on the technical question of Maheder, I think it's your name. You asked for the waterproofing of rammed earth. Actually, the rammed earth it's itself waterproof. The problem that I was showing and how we solved it was about the biological attack, because actually the rammed earth itself, it is a 600 millimeter walls. It's already a waterproofing layer itself, but we protect it with the sealant-based material, what I was showing I can tell you the exact name is called Mapecret cream. That was the product that we used, and usually this product is used on the surfaces of existing buildings in masonry or in concrete to protect it from water. And that application that were used in for rammed earth, it is also applicable to other materials, but with rammed earth works really well. And it is a sealant-based cream that is applied on the surface, and it is absorbed of 1 centimeter. And the second question was the disruptive tests. Yes, we did a lot of them, and your question was actually a smart question, because you were asking that actually when you compact rammed earth from the top, you won't have the same effect in a sample. It is correct. So actually we studied how to get there through a sample, and we did two things. One is to test a sample that have exactly the same weight of a sample that is taken off from the wall. So that's the first, that if they have the same density, it means they are compacted on the same way. And second thing, a bit more complex maybe to explain in a webinar, but we did an equivalence in energy that is used to compact this material. So we ensured that the energy used to compact the wall was equal to the energy to compact the specimen, and with that we had an equivalence of the values that we have of the resistance of the wall and that one in the specimen. In fact, that's for example a specimen that we tested, and that comes from Uganda, and actually is if we compare every lot that was building for every wall, we took off some material to do the test to be sure that the material was the same for every wall, and to test, like in concrete, you do the cubes. We did some cylinders with the principle that I just explained to be sure that the material was correct for every piece of the wall that we were doing. I hope I answered the question. And I'm finished.
There are a lot of questions coming from the chat.
Yes, sorry, I think we have some problems in the connection with Fasil and Rachel, but we have a lot of questions in the chat. So may I ask Raul, Valentina, and Massimiliano to go through the questions? The time we can have Fasil back, hopefully soon.
Yeah, the first is about the School of Architecture, Ethiopian School of Architecture. I think can compare the experiments made with the rammed earth of the School of Architecture, EiABC. I don't know. We don't know exactly the experiment that has been done. If you can share, that would be fantastic, so we can try to imagine what's happened. Okay, this is Massimiliano says a water repellent was painted on the rammed earth, and I would it will stop the water into the wall, but will it not stop the rammed earth from breathing as it is a natural material?
I can answer that. Yeah, yes, it is a natural material, but it is compared to a masonry wall, the technology. So is not you don't want a wall of a hospital that actually let the bacteria, the biological attack inside, and everything like this. The breathing is mostly done from the openings, like in every other building. Like every other building, what was really important for us, it was to prevent being a hospital, to prevent all the biological attack, the bacteria, to finish there, and that was the goal. We're doing a hospital, it has to be the safer place on the city. So that was the goal, and we respected it. And the massivity of the material is also helpful to keep the comfort inside, and to have what Valentina was explaining for the temperature delay. So the goal was more than respected with this technology, and we're pretty sure that was the correct technology. Okay, Raul.
Yeah, there has been a lot of work trying to find a seal system that it was as natural as possible, so to prevent from water, but also to let the transpiration of the wall. Of course, this can be something that in the future can be developed in a different way. Right now, we found this solution with our partner, that was MAPEI. Definitely, we succeeded in the result of getting a good prevention for water, but in terms of hello, I see everybody's disappearing from Ethiopia.
I think they can hear you.
Yeah, they're just in another
okay. Yeah, okay.
environment, but they're listening.
So I think this could be a very interesting issue to develop in the future. There are more questions about Rayendra Kunwar. Sorry for my pronunciation, but also try to develop sections such as columns can be used for load bearing. But on the major concern was the ramping process, as we were. Can you switch? Oh, yes. Ramping process we were doing manually, consistency was not available, and that created multi-layers of different compression. What kind of process suggest will be adapted to local use without compressing strength? This is, of course, this where what we were talking of scaling. It can be done manually. At the beginning, we did some experiment, as you were seeing on the first picture, using manual compression. It's doable. Of course, you don't reach that resistance that Massimiliano was talking, but definitely you need to train the people. I mean, it's issue also of skills of the people. So I think I don't have a number. I don't know. I know if Massimiliano has number with manual. Of course, we had a compressor with a compressing hammer. That, of course, it's not a big technology. It's doable, but of course then you need a compressor. You need gasoline to make the compressor working. I mean, of course, if we look at the whole process, we should put also the oil that has been used for making the compression. Okay, that's the next step in the future. The accounting of energy that is embedded in the process. That this is the next frontier. It's called energia in Italian, MRG. So this is very interesting because, of course, if you want to lead to an extreme process of reduction of CO2, this should be taken in account. So, of course, if we scale down to a smaller example, the hand compression could be a good issue. And I would like to answer to the next question that it was talking about interlocal rammed earth. I think that is an extraordinary good technique. It has to be used properly. We did a small experience in Senegal, actually building a community house in a remote village, just giving instruction to the people of the village, and they build up this community house using interlocking bricks. I must say the quality of the bricks, of course, we use a bit of cement. I mean, that is part of the game, because you can do it without, but the result would be not good enough. So the point is, I think that talking of the future, we have to drastically reuse of recyclable energy, not recyclable material, but we have to talk about durability. And interlock bricks is an extraordinary good material, but there are two main issues. You have to have a good foundation, completely isolated by water, and you have to cover the bricks from direct rain. And I think since you are talking of working in a rural area, I think that it's a good technique. There is a very interesting manual produced by ARUP some years ago, together with, I think, UN Habitat or something like that, that was giving quite a good instruction about that. I think that the failure of this technology in a lot of countries in Africa, as far as I know, for instance, in Uganda, it's due to the bad use of the bricks. Of course, if you use round earth bricks just putting on the ground, it doesn't work, because the water will destroy the bricks. But if you have a good basement, maybe using some concrete and waterproof, and then you cover it properly, it works pretty well. I mean, my experience is very good. And actually also aesthetically, it's very nice bricks, very useful, very, very easy. And I must say, going back to what we were talking before of the embedded energy, this press machine are very efficient. I mean, you don't have a big production, of course. If we are talking of industrial production, it's not that the issue. But the balance between the cost of the machine, the result you can get, I think it's a great option right now. Next question.
There was an interesting question about termites.
Yeah.
And if there are, it's full of termites, and that's why the project, the roof and the structure inside it's steel. The first version of the project it was with wooden beams and wooden columns, but we couldn't do it because it's full of termites, so we couldn't build anything with wood, not even small parts of the building of connection, anything. Even the layers between insulation and then the finishing of the roof, we wanted to put a wooden board, and we took a piece of it and we tried to put it just there to see how the termites would react, and they've eaten everything. So we tested also how the materials would react with if they had also a small percentage of wood inside. We tested directly on site, so that was a big problem. I mean, solved with no use of wood. And then so finish wasn't really make sure. So there were other questions about humidity, but I think Massimiliano answered already. And longevity of walls, of course, all tested. Massimiliano talked about they were the scratch tested. They were done in order to see how the wall would react in the future. of course, we don't know. It's so we don't know in 100 years what will be there, or in 200 years. But some tests have been done in order to prevent. Max, if you want to say something about it.
Yeah, maybe add just a few words on that. We did some tests that usually are done on concrete, and that actually simulate the aging of concrete, and we did the same thing on the rammed earth. And actually, that push a little bit forward the temperature and the humidity in a certain condition and makes the material older. And we saw a good reaction, I would say. There was a pretty good reaction on the results. It's hard to give a number to these tests, but we saw a good reaction, and so that's also why we decided to go forward with these choices. And the time will give for sure an answer, but for an image that I showed before, for example, with the right treatments anyway, it's pretty evident also after 1 year of how the material is changing. So on the mock-ups, we did the mock-ups, and with the construction started like 2 years later. So already you can see in the first 2 years how the material is going, how the resistance is changing, how the surface is changing, if it is damaged or not. And we saw and we continue with these choices and with this technology.
Yes, one thing, if I may, are you answering other questions? I have 2 or 3 questions and one. Yeah, Raul?
Yeah, go ahead.
Yes,
Sure.
Yes. I want to ask you these very general questions of observation. The project you showed us, and all your projects are very interesting. Actually, I saw a presentation of your work, the hospital, the Salam Hospital in Sudan, in the UIA in Durban. I was very fascinated by it. So congratulations for that, and I hope this one will also go into some kind of international recognition, if it's not already in that. Now, the big question we have in the practice in this country is we are slowly, or let's say step by step, going into sustainable construction and sustainable architecture, using different kinds of natural materials, responding to climate change and so on. But how do you interest your client? I have 3 questions, as I said. How do you interest your client? Because in this kind of work, when you talk about solar, they will always raise the question of technology, the question of cost, and so on. So, and then in your project, I saw that you have a lot of trials, experiments, which most clients are not interested. Maybe you had a very special client who, or the organization, was interested in really committed to this kind of building, to this kind of architecture. So the trials, the engineering was, I'm sure, taking time. That at the beginning you mentioned the process, which is, when we saw the project, it is really a process from design to actual implementation. So how do you convince a client? My other question is the training aspect, the realization. When you realize a project like this, do you, how much is the local involvement? Did you bring a lot of Italian companies to do the work, or was there a lot of local involvement, or how much knowledge transfer is there? Because one important aspect of sustainability is that the project, once you go, the people who run this building need to know how it operates, how to maintain it, and so on. And the final question is a detail, which is, your rammed earth, when you make a rammed earth building with wind and so on, there's always these pieces falling out. So inside you have painted. So what kind of technique have you used to make the paint stay and make it also very, you know, a hospital has to be very clean. So how do you keep it clean and keep that surface not from falling? These are my too many questions, but sorry.
So
Thank you.
we need one more day.
Yes, yes. No, briefly, just touch briefly what happened.
No,
you don't have to answer all, but just.
No, I think that your question about the client, it is a big question. I mean, I must say that it's not a question in your country or in Uganda. It's the same in Italy, you know, because at the end of the day, the client is saying, well, why don't we go for the easiest option? No experiment, the cheap and so on. So we have to fight for that. I mean, we are an avant-garde and we have to fight for that because climate change is here and sustainability is not anymore an option. So the point is that we have to make people to understand that sustainability is not more an option. It has to be the base of a project. The first project I show you, the one with Aga Khan, that it is the project where the client, the Aga Khan, that of course is enlightened client, but anyway, they have a very tight budget. Okay, they came to us and say, we want to have the super sustainable, super beautiful, whatever, with the budget we are using for a standard hospital in Kenya. Good. Okay, let's sit down and we start to work with them. And of course, maybe we start from here and we reach here. I mean, I'm realistic, but if we were starting here, we would have reached here. So the point is that it is possible with a clever approach, because I must share with you what's happened with the hospital in Kenya. That of course, at the beginning, we had a lot of dreams about the sustainability. Then, of course, we faced with the budget, but the hardcore of the project, that is the passivity of the building, stays there because it doesn't cost. If it's well designed, it's there. So if you have good ventilation flow, that's not necessary. It has a cost. Of course, a very tight client can say, okay, also that empty room for ventilation, it is a cost. But let's say we have to have a sort of clever and enlightened client. So with the hospital in Kenya that has been completely run with the, let's say, with the local, how can I say, flow, it is doable to reach, I would say, a good standard in terms of sustainability, of recycling the water, of natural ventilation, not just to put an IC to cool the whole hospital, but try to work with a clever ventilation flow and things like that. So this is something that I'm also in Italy, I must say, you know, at the university, sustainability, it is still an option. It is not the starting point, you know. So it has to be, I always say to the client, to the students, you know, sustainability is not anymore an option. So the new generation of students has to think about, to invent something where you can balance budget and sustainability. Then we can open a big window. What is the economical balance? You know, because of course, in Addis, I know that big housing development and dwelling. That of course, if you could just go for the budget, okay, then you can build with $400 by square meter. But in the long terms, in terms of sustainability, also in terms of social sustainability, what is the real cost? I mean, this is the point, and this deals with the politician, deals with the university, and I insist on the point of really costing a construction, not only in terms of money. I know that this is the cost, but it's like, you know, of course, if you say 1 liter of gasoline, it's $1, whatever it's in Ethiopia or in Italy. The point is that as far as we still consider 1 liter of gasoline $1 without counting environmental, social consequence of that energy, it will be, of course, no comparison with sustainable energy. It is coming now very close, but the point is that we have to face this element in the future, to accounting the environmental and social cost within the economic cost. Of course, the clients say, well, at the end of the day, I want to build with $400. That's a challenge. I mean, we prove with our small experience, it is possible to do with $400 a building that has this approach. Of course, the project of Renzo Piano, it's a big experiment, but the other project I showed you, they are projects with a very little budget. I mean, can be 500, 600, 800. I mean, there is the whole range. Of course, if the client is asking the project of Renzo Piano with $500, you say, well, that's difficult. A local involvement, that's a big issue. That's a big issue. I must say, I have two examples with emergency. Emergencies is building and running the hospital. So in terms of strategy, of course, it depends on different countries, but in terms of health strategy for the future, the idea is to build the excellence so the whole country can improve with excellence. What's happening in Sudan, when we built the cardiac surgery hospital, everybody was saying, well, what are you doing in Sudan where the people are still starving and you have malaria and so on. But what's happened, that hospital, first of all, the cardiac problem is a major problem in Africa as well, first of all, that needs treatment. So that's right. The other point is that if you set up the benchmark at this point, the other hospital has to grow and to face that benchmark. So this is one thing. The approach of the Aga Khan, it's much more rooted with the local context because they are there in the country. And I think that both the process are, in terms of healthcare, the building is part of the healthcare process. It can be separate. I mean, what's happened, I have been working with other NGO, you build a nice hospital and then you give it to the local authorities that are still running as it was before. So it has to be a process of following together the same line. And this is, again, sustainability is part of this. Has been very interesting with the Aga Khan Hospital that we work with the mechanical engineer of Kenya to design something that was available and also in the maintenance mood of that country. So I think going back to finalize this question, I think that we have to stop to have this process of top down, wherever top comes. That can be the Italian NGO, the American, the Minister of Health, or the donors. We have to start to work in a more collaborative way where all the parts are part of the process. That is the designer, the engineer, the users. I mean, it's essential to involve the users in the process. And this is a way also that has to start from the university, because I'm saying for what happened in Italian, we have still this approach of top down. You are the architect, you are the engineer, you are building, you're doing something. It's not that anymore the time. The collaborative process is going to be the next step in the future. There's no way. It's like sustainability. Participatory process is not an option, like sustainability. So the two things are together. Well, internal finishes. Well, anyway, we use gyps board, and so it is a standard finishes. Nothing special on that.
Yeah. Yes, thank you. So I think these are some of the questions which are coming. You are watching the screen, yeah? Yeah. I think you have touched some of the questions. One thing I see is, I think you have touched also the question of space and so on. What do you say? Everybody's complaining about connection everywhere. This is the digital divide, Africa, the digital divide.
Fasil, I think positive. We can do it.
Yes, we did it.
Yeah, so let's see positive.
Yes. No, you are. I think working in sustainable architecture, you have to be very optimistic.
Yeah.
You have to be very. You really don't give up. You try. We can see that from your work, and your work says a lot about that. I'm just trying to bring to summarize some of the questions. If there is anything that you have not touched.
There is a question for Valentina. How sustainability was design process using a BIM and other things?
The BIM, yes.
Yeah. Sustainable, you mean feasible? It was feasible. It was doable, of course. We use it halfway somehow, BIM. So let's say we had structures. So the structural project and the architectural project was with the BIM technology. So everything was in Revit and was in the shared project, and that was very, very useful because it's a way of designing completely different. You don't have to send me the drawing. So you know how it is. So you call, can you send me the drawing? No, you see everything live. So you have a platform. There is a cloud platform, which is this platform in the States, and everything it's loaded on this server. So our project were loaded there, and they were working together all the time. So I could see all the changes of the design process of the engineers that were in Milan at that time. So that's why we showed that map that was very complex in from the geographical point of view, but very easy on the process. So I said halfway BIM because then the plant and all the mechanical and electrical project was not on BIM. So it was let's say 2D design, but somehow we tried to put them together anyway. So it was not so hard because we managed to put it in the model as well. And then we like anyway to draw and to print out and to do per hand drawings and to keep have the relationship with the design on the paper. So it was a mixed method somehow. The interesting part was this interconnected and collaborative system. Anyway, we had, and with the site as well. So the site could check the model and the developing of the project even during the site construction. So it was a very interesting process.
I think that there are signs that we are reaching the 2 hours. So.
Yes. We have to close. I just want to put maybe we would like to give you the last remarks, but I will put not a question, but like if you would also comment on what you could give an advice, because a lot of your audience is young architects, aspiring young architects who want to do, who want really to employ, or let's say to bring a sustainable architecture using rammed earth or any local material in a very modern way for social and other projects. So if you have a general comment, all the three of you, just very, very short comments, and probably maybe some of the tricks or the techniques. I think, Raul, you mentioned some of it earlier with my question, but if you see that very briefly, because we are approaching now, we have, maybe I give you maybe 1-2 minutes each, and then to wind up, and then I will take the floor to close. Okay, thank you.
Yeah, I'm just one thing. I put on the chat two links. One is for this work we did with Arba on natural insulation, and one is the project. It's an open source project we did in Senegal using interlocking bricks. So all it's available. You can just download the project and you can confront on what's happened. So I don't know if this is. Luca, if you can share to the audience. I just would like to finish saying, think sustainable. I mean, the point is that it's in our brain, the sustainability. So of course, if the limitation of your client is just saying, just use a concrete wall, of course, we know concrete is not the most sustainable things in the world, but you can think sustainable also that. Maybe reducing the 10% of concrete, maybe shading the concrete, maybe avoiding, if possible, part of the concrete. So it is a way. So that's why I say think sustainable, because it's not anymore an option. Whatever you do, even if you do a restaurant, and it's a way of thinking. Talking about the future, it's not just solar panel or a lot of, I mean, what is evident is the way of thinking. So I just would like to recommend to think sustainable. Finito. Fasil, we cannot hear you.
Valentina, can you say something? Do you want to say something? Very short.
Yeah. Yeah, I can say that I was very fortunate and very, very lucky to be. I'm young too, but I was very, very lucky to be in such a process. And with TAM, each process is very interesting every time. So, but I see that this sustainable architecture, it's spreading out everywhere somehow anyway, because even businessmen now are thinking in sustainable way. Also because they have noticed that that's a business as well. So maybe what Raul was saying, yes, we have to think sustainable because it's the only way, but maybe to convince the client, they have to see also that it's interesting also from the business point of view, because they do business anyway. Most of the clients who build buildings, they do business and they're interested on that. But they have to see also that showing to the public a sustainable building, it's also a good publicity for them. So it's marketing as well. So if we have to think in their mind, in their way of thinking, so maybe to bring them in that way, we could see from their side somehow. So it's sustainable. It's also interesting from the business point of view.
Thank you, Valentina. Massimiliano, do you have some advice, not only for architects, but also for our engineers?
First of all, thank you, Raul and Valentina. I agree totally with what you're saying, and I would like to say something about this project. What it was wonderful was the collaboration. Raul mentioned this term before. The collaboration was one of the first needs for this project. We were working with for a ONG, so there were a lot of donors, a lot of material were donated, and that was something that involved really a lot of good people that just wanted to reach the goal of doing this project, doing this well, and doing it sustainable. And I think that this project is not just a hospital, but should be also a model to understand that many people want to be good, and there's a lot of people that want to do things right, and not only with the economical side, but anyway, there's a lot of people that were really interested in pushing forward this project, and so it's a big thanks should go also to these people, and that made the final made actually the final project constructible and what we can see now, and we look forward to see the opening of the hospital and the function of the hospital.
Yes, we are also very eager to see this hospital open and functioning, and I think you have you are role models. We things that has not been experimented, that has not been tried. You have tried it. Congratulations for that. And we will learn a lot from that. And it is with people like you who are really, strong, convinced and committed people who will be, of course, helping all the other young architects, engineers, and so on, who think in a very sustainable way, will use the methods, the knowledge that you have built, that you have tried. We will also use it. And I'm very grateful for your presentation, for your time, Raul, Valentina, and then Massimiliano. And also thank you very much for the Italian Institute, Cultural Institute, for organizing this and making us meet virtually. But I think in the future, we hope we will see you in person and also visit your project. And if you have anything to share with us, please do it through us and so on, through our association and also through the Italian Cultural Institute. Thank you very much. I thank you really from the bottom of my heart for your time, and not only for presenting this, but also for doing such a project and being such convinced professionals. This is how we can save the world. Thank you very much.
Thank you very much. Next time, face by face.
Yes. Thank you.
Bye-bye.
Thank you. Then thank you for the audience for tuning in and being attentive. Yes, the video. Yes, I think this was very good. In spite, we fought with this internet. And thank you for it was Luca, no? Luca, thank you very much for your for managing this difficult weak internet connection we have. But it was really, thank you very much, and it was excellent. It was excellent.
Luca wants to launch a video now. He's going to. You can tell Luca you are launching the last video.
Yes, you can launch the video now. Yes, for the audience also. Yes, great. So. He was working